Okay, welcome to video 7.2. Here we're going to talk about recursive versus explicit formulas. So if we look at our first example, if a sub n equals negative 4n plus 5, find the first four terms of the sequence and figure out what type of sequence this is and why. So first let's look at a sub n equals negative 4n plus 5, and to find the first four terms, well, I'm going to put 1 in place of n first. So to do that, I write a sub 1 instead of a sub n, and then everywhere I see an n, I replace it with the 1. So negative 4 times 1 plus 5, which you can then put into your calculator, and you'll get the answer of 1. So a sub 1 is 1. Okay, now it says that I need to list out all four, so now I'm going to do the same thing, only I'm going to put a 2 everywhere I used to have an n. And when I do that, I get negative 3. And then again, I'll do the same thing with 3 and then 4. So when I put 3 in place of n, and then everywhere I had an n, I replaced it with the 3, I get negative 4 times 3 plus 5, which gives me negative 7. And then with 4, negative 4 times 4 plus 5 equals negative 11. So this sequence is arithmetic, and this formula is explicit, meaning that every single term I want to find, all I have to do is take that one number and replace n with whatever I am looking to find. So the sequence here is arithmetic, and I know that because if I look from 1 to negative 3 to negative 7 to negative 11, if I subtract 4 or add negative 4 every time, so that'll get me to the next term, and that's why the sequence is arithmetic. Okay, example 2. If a sub n equals 16 times 1/2 to the n power, find the first four terms of the sequence and determine what type of sequence this is and why. So again, first four terms means everywhere I used to have an n, I'm going to replace it with first 1, 2, 3, and 4 so that I can find the first four terms. So the first one, I plugged in the 1. A sub 1 equals 16. I just replaced 1/2 with 0.5 just because it's easier to type on this, but you can write it as 1/2 to the first power, and I get the answer of 8. Now I'll do the same thing, only I'll put a 2 in place of n this time. And when I do that, I get 4, and you can again just put that all into your calculator. And then I'll do the same thing with 3. And when I do that, I get the answer of 2. And then lastly with 4, and I get 1. And if we look here, I had an idea of what this was going to be just by looking at the formula, but if I look at the pattern as well, I can see to get from 8 to 4 to 2 to 1, it looks like I'm multiplying by 1/2 each time. So that means that this is geometric because it is a common ratio. So I wrote here the sequence is geometric because r equals 1/2. Common ratio is 1/2. So these formulas look and work just like all the functions that we have seen this year, but some formulas only give you the pattern to make the sequence. So if a sub 1 equals 4 and d equals 7, find the next three terms. Why is it so tough to find a sub 25? Well, first, okay, so if I say a sub 1 is 4 and the common difference is 7, how would I find the next three terms? Well, I could write out the list and just use the common difference to move from one term to the next. So if the first one is 4, to get to the next one, I'd add 7. And that would get me to my 11. So I have my a sub 1 first term and a sub 2 second term. To get to my third term, I'm going to add 7 again. That'll get me 18. And then if I add 7 again, that'll get me a sub 4, the fourth term, which is 25. Okay, so that was my next three terms. Why is it so tough to find a sub 25? Well, it's tough to find a sub 25 because we would have to add 7 each time. This method would take a long time, and I would have to write out all 25 terms in order to find a sub 25. There's no way to just give me a sub 25, because in order to find 25, I got to have 24, and in order to find 24, I have to find 23, and so on all the way back until I'm at a sub 1. So again, I would need that whole list. So a formula for this sequence in exercise 3 is a sub 1 equals 4. A sub n equals a sub n minus 1, which is just another way of saying the previous term, plus 7. It gives you the first term, a sub 1, and a formula for finding any nth term, a sub n. In the formula, you are always given what you do to the previous term, which is a sub n minus 1. This type of formula is called recursive.